How is everyone today? I'm so excited I'm finally here. I was very excited. Ooh, that's how excited I am. We finally got everything arranged, and I was going to come last year, and then I had to cancel. And Sharon didn't kill me because, I don't know if y'all heard, but like Dora joined Google. Although it's super fun because I still get to tell Google to stick it, and I like do my own thing, which is more fun because now I just get to do more research and more fun and more strategy. So this is tips and tricks to make your DevOps awesome, but it's really tips and tricks to make your organization awesome. Because, I mean, tech is fun, but it's really just about tech to make our organization better. But really it's about things to make our work better. Because I do a bunch of research now, but I really started out as a developer. And then no one was running my systems, so I was a sysadmin for a while. Is anyone here? So who here is a dev who does development? Who here is a sysadmin? And who here ended up being a sysadmin because no one else was running the systems? Right? And then I ended up doing hardware because no one was taking care of that either. So I did hardware for a few years. And it seems like so often we end up running systems because we love the systems or like they keep breaking. And so we end up having to, or getting to run all of these systems. And then I kind of stumbled into research because I had all these great ideas and other people had all these great ideas and were sharing stories. And so I would go to management, or I did consulting for a little bit, and I would go to the teams and I would say, let's do this, right? And so we have all these great plans and ideas. And management would come back and they would say, yeah, but that won't work here. Have we ever heard that before? I'd be like, so I decided I would go get a PhD, in part so I could figure out which types of things work generally, also so I could win these fights with data. So this is kind of a summarization of what I found over 12 years. Don't do math in your head. Or, so the State of DevOps report and Accelerate and a bunch of stuff is kind of the summarization, specifically what I've done over the last 6 years, but I've been doing this for about 12. And I've kind of continued to tinker and advise and work with companies for several years and swear at systems, because that's really what works, right? Is just swearing at systems. You don't get that joke, but it's true. Okay, so that's me and my background. So we've done kind of the work around State of DevOps report. We've done Accelerate. And then I'll focus today some on what came out in the 2019 report. Have y'all taken a look at the 2019 report or heard of it? 2019 is dope. I mean, I say every year that it gets better, but it's true. I love all my babies, but I love some of them more. So today we'll go through, is DevOps even a thing? We'll talk about how to get better when we make technology, aka choose your own adventure. This year I did extra because I suddenly had like more resources, which was exciting. We'll talk about performance and what I mean when I say performance, because when I do research or measurement, and by the way, a lot of this is similar when we work in companies, right? When I talk about things, when we measure things, we have to be pretty specific. So when I talk about performance here, it's speed and stability. I'll also talk about productivity and getting work done. And I'll probably go on a little rant about what I don't mean and when we keep like kicking ourselves in the butt. I'll talk about culture, because allegedly I hear culture matters. Talk a little bit about open source and then how to scale our transformations, because we keep sucking at this. Last night, I don't know if anyone follows me on Twitter, but I ended up in a hotel lobby, like little lounge, and heard these like tech bros ranting super hard about how amazing they were and also like destroying their transformation and breaking their culture. So scaling your transformation the right way, we'll talk about that. And then I'll wrap up and give you a quick list of all the things I didn't have a chance to talk about. Does that sound okay? Or do we want me to just like throw that out the window and talk about something else? We can do that. When I talk about DevOps, what do I talk about? I'm generally talking about speed and stability, and I measure this with what people have started to call the 4 key metrics. So when I say speed, and you're like, girl, there's 5. I can count, I swear. We're usually talking about the 4 key speed and stability metrics. So speed is lead time, code, how long it takes to go from code commit to code running in production. I know we do more work before committing code, but if I focus on code commit to code running in production, this is the very predictable portion of what we can do, which means we want to reduce variability here. Right? This is the highly automatable portion of what we can do. The stuff that happens before this is the creative portion, the R&D portion. We expect more variability here, right? This is still important, but it's very different. Does that make sense? Okay. I'm not saying it's not important. I'm saying it's understandably, demonstrably different. So that's why we focus on lead time. It's also that measurement process is going to be different. So that's lead time. Also, fight me later. I know there are like different ways to call this. Some call it lead time, some call it cycle time. This is a known problem. Don't yell at me. This problem existed before I came around. Okay, deployment frequency, how often we deploy code. Okay, these are our speed metrics. Our stability metrics are 1, change fail rate. How often you have a failure when you push code to production or your like pre-prod environment. And now it's not just like an epic failure. Does it require time, attention, some love? Time to restore. When you do have some kind of incident, how long does it take you to restore that? Okay, so these are our 4 key metrics. Starting last year, we also added availability. So this is the promises you make and keep to your customers, right? Because we are now in cloud and availability environments. So our customers, I'm not gonna say they didn't matter before, but when we were in like packaged software environments, things were a little bit different. I will say that, whatever we wanna call it, doing the DevOps, I do work with companies that are still in printed packaged media that are absolutely using these 4 key metrics and several of like DevOps concepts to track what they're doing and to improve their performance. Okay, so when I say DevOps, whatever you want to call it, when I say transformation, when I track performance, this is what I'm talking about. And many, many companies and organizations throughout the industry are using this to track their performance. Now, we have movement. If we see what the industry is doing from 2018 to 2019, here's what we see. Elite performers have almost tripled. They've gone from 7% to 20%. Last year, they were a subset of the industry. Now they've broken out into their own group. So many analysts have said DevOps has crossed the chasm. Our analysis kind of echoes that. The nice thing here is that we can see that it's kind of a safe bet now, right? Some highly regulated organizations or some very risk-averse executives have said, we don't want to do this, we want to be careful. Like, chill. Everything is fine. Make this bet. Developing and delivering software in faster cycles that's not just agile, because agile is only faster, tighter coordination between the business and development. So now business development and operations, this is now a safe bet. Okay, so that's the elite performers. Now take a look at the low performers. We see shrinkage here. This is a good sign. It means people are getting better. Now take a look at medium performers. This is interesting. Some of this growth comes from low performers moving up, but some comes from high performers moving down. So last year it was 48%. This year it's the comparative 23 plus 20 is 43%. Why is this? Some is probably some organizations struggling with complexity. Some is probably struggling from increased controls. We see many organizations panic and just introduce change approvals. I don't know if anyone has seen this. I'll talk about this in a little bit. Also, many organizations do this maturity model thing where like, we have reached level 5, we have arrived, we are done, and they will sit and they will not do anything. They will stop improving. They will stop getting better. And in a world where technology continues to grow in complexity, you can't do that. We get worse. We slow down, and the rest of the world moves on. So when organizations say, but when will my technology transformation end? When can I stop investing? The answer is never. And they look at me, and laser beams start shooting out of their eyes. They get really mad. They're like, but I want to stop investing. And I'm like, well, so when are you going to stop investing in customer acquisition? And they look at me like I'm crazy. And I'm like, that's what technology does for us. Technology helps us deliver value. It helps us keep up with compliance and regulatory changes. So it's not going to end. So apologies, this is an eye chart. But when we look at what elite performers look at, they can deploy on demand. Their lead time is less than a day. Their time to restore service is less than an hour, and their change fail rate is between 0 and 15%. The low performers deploy between 1 and 6 months. Lead time for changes is between 1 and 6 months. Time to restore is between a week and a month, and that change fail rate is between 46 and 60%. Those deltas are big. Now, I will note that a few of these stats look like they're similar. They're actually statistically significant, the difference is there. And so one of my co-researchers this year, Dr. Dustin Smith, did some analysis for me and pulled together some graphics. So you can see where, like change fail rate, it looks like it's similar for medium, high, and elite performers. And you can see where medium and high do have some overlaps. But elite actually pulls above. So I suggest you check out the report, because what we do is we report the median, not the average, because the can I do a quick stats note? The distribution isn't normal. So I report the median because that's more accurate to report, but there are significant differences, and you can see when you look at the report how they lay out. So we did include that in the appendix this year. Quick side note. Okay, so when I compare my elite performers and the low performers, this is what I see. I see 208 times more frequent code deployments, 106 times faster lead time from commit to deploy, 2,600 times faster time to recover from incident, and 7 times lower change fail rate. And people say, okay, why? Why does this matter? Well, it matters because the marketing team loves numbers like this. Also, executives love it. It means that we can, again, deliver features faster. But the security teams love it too, because we can keep up with security threats and security responses. Who here is loving Kubernetes, right? Kubernetes and microservices. The faster we can turn over our infrastructure, the harder it is for attackers to come after us. The better that we can keep up with vulnerability and security threats. This really is a holistic solution for our company. Also, auditors love it. We can keep up with compliance and regulatory changes, right? I spoke with someone in a government, and they were like, we don't have competitors. Well, governments change. We have compliance and regulatory changes. We can patch our infrastructure and roll infrastructure better and faster. This means a lot to us. As I mentioned, we added availability. It's about customers. So this measures how well teams define availability targets, track their current availability, and learn from any outages. To dig into some of these things, I'd look at SRE practices and metrics around this, SLOs, SLAs, and SLIs. The joke here, day 1 is short, but day 2 is long. We can push that code, but how well do we keep that up? Okay, so we do tech because it's fun. I mean, yeah. That's why I got into tech. Also that, because I like making money. I'm sure we're all here because we like doing tech. But also, organizations care about more than just technology being fun. Technology delivers value. We see for 6 years now that elite performers are twice as likely to meet or exceed their organizational performance goals. Like That's very academic, organizational performance. This covers commercial goals and non-commercial goals. So commercial goals are things like productivity, performance, market share, and non-commercial goals are things like effectiveness, efficiency, customer satisfaction. Okay, so it matters. How do we actually get better? People will say, well, Nicole, I can't just decide to deliver software faster and more stably. So we actually do predictive analysis to see which types of things help. So this is the choose your own adventure portion of the research. So I'll walk through the research models. Anytime you see an arrow, a line and an arrow, that's predictive. So the things that improve performance, which is speed and stability, culture, change management, cloud, technical practices, and disaster recovery testing. And then this year, we added productivity. And so which types of things help with productivity? Now, we've done this over several years. We've done it over 6 years. So I have like a giant, ridiculous diagram where we found over 20 things. I think it's almost 30 capabilities now that help predict productivity. The nice thing about our research is we've done this from a completely tool and vendor agnostic perspective. And if you go to, I think I've got the link at the end of this, cloud.google.com/DevOps, you can see what all of these capabilities are. So for example, CI, you can see what types of things make CI predictive. Continuous integration, we know what this is, right? I said CI last week, and they're like, what's CI? And I was like, why are you in this meeting? We know what makes CI actually predictive. And then you can use it as an evaluative framework. You can say, does my tool, whether it's been purchased or homegrown, does my tool do these 4 things, right? And we've laid this out on cloud.google.com/DevOps. So, improving performance, right? So that's the model. That's fine. That's how you read it. Just kidding. Okay, I'll walk us through it. So here's how we've built out the models in this year's report. I started with putting a dark black border around the things that are typical team or organizational goals to kind of draw your eye there. And then you can, if you want, you can work backward, because then you can say, how do I want to improve that? Like I said, anything that has a line and an arrow is predictive. And so if you want to say, I want to improve SDO performance, which is speed and stability and availability, work backward from there. Or let's say we want to improve speed and stability. Which things improve that? Well, that's going to be culture, having a clear change process. Having a heavyweight change process negatively impacts it, so it reduces it. There's a minus on that arrow. Disaster recovery testing, continuous delivery, and cloud. Does that make sense? Now you've got your list of candidate solutions, and then you can start from there. Does that all make sense? Okay. Oh, I have a clicker. The power. So let's dig into one, cloud. Cloud we started looking at last year. So the interesting thing though, is I would talk to people and I would say, well, I'm using the cloud. And I could talk to execs and they would say, well, I just spent all this money on cloud and nothing changed. Or I could speak to developers and they would say, well, we did this cloud thing, but nothing actually changed in my work. So we wanted to research it. And we went into the definition from NIST, National Institute of Standards and Technology. So we wanted to actually dig into it. These are the 5 things that make cloud, cloud. So on-demand self-service. You can't like put in a ServiceNow ticket, wait 2 weeks for someone to approve it. I award you no points, may God have mercy on your soul. If anyone has seen Billy Madison, that's where it comes from. I'm not actually that mean. I'm a little mean, I'm not that mean. Broad network access. You need to be able to access the cloud from several different types of devices. Resource pooling, rapid elasticity, bursting like magic, up and down. Measured service, you only pay for what you use. So sometimes I'll play this game where I like make people put their hands up and then drop their hand. It's really interesting. Drop their hand anytime they're not doing one of these. Because what we find is that we ask people early on if they're using the cloud, and then ask them later which of these pieces, capabilities, again, right, I said you can use this as an evaluative framework, they're actually using. What we find is that only 29% of respondents meet all 5 characteristics. So the part where they're like, oh yeah, well I spent all this money on cloud and I'm not getting the benefits, because you're not doing it. I mean, I bought a membership to the gym and I'm not getting, okay, except now I am, like my legs are really sore, so if I'm walking funny, I'm sorry. Like you actually have to do the work if you want to get the benefits. And for the people who do, elite performers were 24 times more likely to have met all 5 characteristics than low performers. So if you actually execute, you see the benefits. Last year we did the same analysis and it was we were slightly different, but it was 23 times more likely. So again, we're seeing consistency across years. Okay, we added something new this year, code maintainability. We see that this positively contributes to continuous delivery and helps reduce technical debt. Stay tuned, I'll talk about tech debt soon. So what's code maintainability? It's systems and tools that make it easy to change code maintained by other teams, find code in your code base, reuse other people's code, add, update, migrate to new versions of code dependencies without breaking code. So things like avoiding that diamond dependency issue. So if you had something like this, if you have something like this, does that make sense that this would be helpful? Right? This makes sense. This helps. This helps make our code and coding and development better and faster and easier. But we wanted to test it. We wanted to see if this was generalizable outside different contexts. And it is true. Okay, yeah, read the report, going to read the report. What else is new? We wanted to dig into productivity. Okay, so productivity is, again, I've got that box around it. What contributes? Cultural psychological safety, useful, easy to use tools. This makes sense, right? We want good tools. I can't tell you how many times I had to use like awful tools because that was what my organization approved. Made it through like the procurement process. Internal and external search, right? If I can, what's the joke that like a degree in computer science is really just being able to Google or Stack Overflow? Internal and external, because sometimes I need to search my internal knowledge base to find that like ridiculous config file. And technical debt reduces productivity. Now, the nice thing is that productivity also helps with work recovery. It's an academic term, but we used it because it's that right mix of like work-life balance and disconnecting from work, which then reduces burnout. Okay, but what do I mean by productivity? Productivity is the ability to get complex, time-consuming tasks done with minimal distractions and interruptions. Productivity is not lines of code written, because too many lines of code is just bloated code bases, which gives you more technical debt later. Lines of code written is not story points, because here's the problem. If I have a story point, if I have like goals of story points and you have goals of story points, I will never help you. Because if I help you, then I don't get my story points written. So some people are like, this is hard to measure, but many researchers are starting to measure it this way because this is actually a very good measure for an overall holistic capture of productivity. And this is the kind of productivity that helps us leave work at work. And we know what this feels like, right? If we get a bunch of complex work done and we go home, we can kind of shut our brains off, right? However, if we get a bunch of, you know those days where like we were busy all day long, but somehow we got nothing done? And we keep spinning on it all like constantly all night? We just fry. So technical debt. Technical debt reduces productivity. It was introduced in 1992 by Ward Cunningham to describe what happens when we don't maintain what he calls immature code. So people have wondered if technical debt is really a thing. Do we know technical debt? Do we feel technical debt? So we wanted to see if there was a way to capture this and measure it in a scientifically rigorous way. And these are the things that measure technical debt. Known bugs that go unfixed to favor of new features. I feel attacked. Insufficient test coverage. This is super real. Problems related to low code quality or poor design. Code or artifacts that aren't cleaned up when they're no longer used, because we might use it later. Implementations the team doesn't have expertise in, and therefore we can't debug or maintain it. So often we just get rotated off a team, and then the code stays there. Incomplete migration. Obsolete technology. COBOL forever. Incomplete or outdated documentation or missing comments. So how do we reduce technical debt? Okay, refactoring for sure. But what else can we do? We can make smart investments in tooling and technology. So it's interesting because Ward Cunningham's original article, which by the way is super short, it's generous to call it an article. He suggests that what we should do is only have one person maintain very small programs, because then they can always and forever maintain those programs in their head and maintain a complete mental model. Is that even remotely possible today? No, because we have complex distributed systems with several people working on them. So what might a solution be? A solution might be to help people gain visibility into systems and understand what those systems are doing and reduce surface area impacts, right? And so what that looks like is code maintainability. Remember we talked about that, how that's seeing the impacts of changes on code. Loosely coupled architecture, so that when we do make changes, it minimizes, it's not this huge monolith that gives you this huge domino effect. And monitoring, so that we can see the changes. So organizations can make smart system and tooling investments to help us. Okay, I keep hearing this culture thing, allegedly, culture matters. Okay, what does that mean? We've studied Westrum's organizational culture for the first 5 years of the State of DevOps report. Has anyone heard Westrum? Has anyone not heard Westrum? Okay, let me run through Westrum really quick. We have pathological culture. Oh, it was introduced by Dr. Ron Westrum. He's a sociologist. He studied complex, high-risk systems in areas like healthcare, aviation, nuclear power. So when you screw up, people die. Bad idea. Also, he understood and focused on information flow, because when we have good information flow, we understand what's happening. And he also found that this was predictive of performance outcomes. So there was pathological or power-oriented systems typified by low cooperation. The messenger was shot. You shoot the messenger when you get bad news. Kind of shirk responsibilities, discourage bridging, so you stay in your job function. Failure leads to scapegoating, and didn't want to hear any kind of novelty. Just do your job. Bureaucratic culture, modest cooperation, ignore the messenger when they bring you bad news, bridging's tolerated, narrowly defined responsibilities, failure leads to justice, novelty leads to problems. Generative culture, high cooperation, messengers are trained. That is, we want people to bring us bad news so we can find it, service it, and fix it. Risks are shared, bridging's encouraged, failure leads to inquiry, novelty's implemented. Sounds a lot like DevOps, right? Break down silos, blameless postmortems. We realized this, so we started measuring it, found that it was highly correlated to performance profiles, and that it was predictive of performance. Also, Cote, every day there's someone born who hasn't seen the Western model slide. Welcome, now you have. But we'd studied it for 5 years. And so we wanted to study some of the work done by teams at Google. They had found that within Google, so their thesis was that to be able to make the perfect team, you needed to find the right mix of skills. A Node.js programmer, and a PM, and a data scientist, So they studied this across all the engineers at Google. What they found was that that didn't matter at all. What mattered was that you have far and above, number one, psychological safety. You could trust each other to take smart risks. And then dependability, you could depend on each other. You had structure and clarity in your work had meaning and impact. People were like, this is amazing. People were also like, this is bull. This works at Google. They have this ridiculously high interview bar. They have scooters on campus. They have free food. This is never going to work anywhere else. So Dora joined Google, and I was like, can I have your survey questions? We're going to test this in the rest of the world. And we did. And what we found was that this actually holds. So I think that's really important and impactful. We do find additional support that a culture of trust and psychological safety has an impact on software delivery performance, speed and stability, organizational performance, and productivity. So it's not just free food and scooters. This was true at enterprises, at highly regulated enterprises, in places that are using COBOL. This really is important. Okay, is open source still a thing? Allegedly. Community is an asset. High and elite performers continue to use open source the most. And we see that their elite performers are 1.75 times more likely to make extensive use of open source. By the way, this benefits recruiting. Is anyone here hiring? Allegedly, right? It contributes to productivity, right? Engineers who use external information are 1.67 times more likely to be productive. And remember on productivity how we said internal and external search were helpful? This is a huge boon to external search. If you have your own homegrown, home-rolled language, you can't search anywhere else. And tech debt, remember internal documentation was a thing? Who hates documentation? I hate documentation. We need to do it, but like we suck at it. It's so hard, that responsibility bar becomes so high if you've got your home-rolled everything. If you leverage open source, you've got a massive community for documentation, for examples, for security. Everything just becomes so much easier. Faster is better, even in open source. Now, the open source model is a little different, right? Because we end up having hobbyists, different skill sets. So many things are different, but we still see that faster is better even in open source. Committing code sooner is still better. Merging patches faster to prevent rebases helps developers. You help your code maintainers. Also, working in small batches is better. Giving somebody a patch bomb is not going to make you friends. Okay, but I've got a whole organization to change. How are we going to do this transformation? This is how we can execute for maximum impact. Start with foundations. If you're not using version control, start there. Leverage concurrent efforts for maximum impact. Okay, what does that mean? Sorry, I speak academic sometimes. There are some things that you can only do at the organization level. Things like change approval process. Let upper management help with that. At the team level, though, things like testing and monitoring, ICs can help with that. And you can do both of these at the same time. And then focus on constraints. What does that mean? So once you get your candidate list, like things that can help predictively, start with your biggest headache. Maturity models are dumb. Don't assume that every single person will have and every single team will have the exact same path to success. Whatever your biggest headache is, focus on that. Once it's not your biggest headache, look at your next biggest headache. That's how you get better, faster, and most efficiently. It's the best use of resources. Now, we also looked at overall patterns in scaling transformation. We looked at a heat map of strategies by performance profile. This is fine, I just included it. We looked at training centers, centers of excellence, proof of concept but stall, like do you throw in money and then not really do anything with it? Proof of concept is a template. Do you do one and then stamp it everywhere? Proof of concept is a seed. Do you put in resources and then break those people up to kind of scatter them as teachers? Communities of practice, big bang, bottom up or grassroots, and then like mash up, you just do everything. But we did an additional analysis to see what high and elite performers do, and I think this is super interesting. Community builders was the most often seen, because this is what builds scalable solutions that are resilient to any type of thing like reorg or product changes. So what we see here most often are communities of practice and grassroots. What we don't see very often is university. Dojos and centers of excellence are really tough. You can do it, but it's going to take significant resources, because what you've essentially done is created another silo. So it can work, but you're going to need a ton of money and a ton of resources to make sure that whatever's been learned or centered in these brand new silos, like a fancy center of excellence or a fancy new dojo, gets spread throughout the organization. Okay, TLDR, take a picture so you get credit, because I'm sure a couple of you were just on Facebook. Is this DevOps thing even a thing? Getting better, AKA choose your own adventure, and then there we covered performance, which was speed and stability. We also covered productivity. We talked about culture and the 2 ways that we can measure it. And by the way, both of them are important. Shocker, I know. We skipped process though. So if you go check out the website, we've got stuff there. Also talked about open source and how it's still a thing, and it's not real risky. Talked about scaling your transformation, and like I mentioned, there's so much more. We talked about disaster recovery testing. By the way, only 40% of people are doing it annually. I'm terrified. Change approvals and doing it the right way. Pro tip, heavyweight change approvals are a bad idea. They lead to instability. More on open source, more on cloud, and how it relates to costs and cost savings and transparency. We also have an executive summary that's coming soon. So if you go to cloud.google.com/DevOps, we even have a quick check where you can check out your own performance and how you compare to the rest of your industry. Thanks so much, everyone.